person. All right. Welcome everybody to the Introduction to Unity Part 1 workshop. I'm Connor Hartzog. As you can see, I've experience making things inside of this editor. Not all of these things are amazing, but I have experience with trial and error of what works and what doesn't work. So I'm sure from the last workshop that we presented as the XR Club, we went over the basics of what Unity is. But for me, I want to answer the question, what is Unity? For me, it is a game-making software. I know it is a creative tool that goes way beyond creating applications other than games, but I primarily use it to make video games as well as entertainment-based applications. But it can be expanded to go on all sorts of devices, including Macs, PCs, iOS, Android-supported systems, such as the Oculus Quest 2. One of the big hallmarks of the club is your ability to, in the future workshop, develop applications that will run on the Oculus Quest 2. So we're going to begin with our discussion on the Unity Hub. The Unity Hub updates fairly regularly and keeps all of its editor versions on archive, so you can always revisit old projects. As you can see from these older projects I have like warnings on the side here that says that they are on other editor versions. Inside of my installs on this computer, I currently keep like 3 different editor versions just because I want to go back to these old projects without risking any errors. 2020 and 2021 being the most important ones currently on my computer, because a lot of the programming inside of these changes over time. You can always make your older projects into new ones, but not your new ones into older projects. So I like starting with the newest LTS version. LTS stands for long-term support. If everyone could open up on their computers the Unity Hub at this time, we're going to actually create a project for you guys to go through the basics of Unity. So inside of Unity projects, we're going to open up this top left corner and go into the projects tab. Once here, you're going to see all the projects that you previously worked on. At the moment, most of you probably don't have any. We're going to start by opening up a new workshop by hitting this blue button in the top right corner. It's going to open up a new menu. Right now, I'm working in the editor version 2021.3.9 F1. Last week, you guys all installed the editor 2021.3.10 F1. These are predominantly the same. The difference between 0.9 and 0.10 is a patch, which means that every feature on my computer will still be every feature on your computer. So it's okay if those are different, so long as they are still 2021.3 something. From here, we're going to open up 3D Core as our project, so make sure that's selected. If you would like, you can rename your project on the right side here and change its file location. Right now, I just have mine set up to my GitHub so that all my projects can be exported to other computers. You can rename that if you'd like. Then go ahead and hit Create Project. This may take some time as you're creating a project for the first time and depends on computer speed. So in the meantime, some of the most popular applications have been created with Unity. One of my favorite current games is Risk of Rain 2. That is a 3D arcade-style game, roguelike, that allows you to go through multiple levels, has many chaotic elements going on with projectiles. The most popular virtual reality application currently on the Quest 2 is Beat Saber, which is entirely made in Unity. But other applications can be created with Unity, such as the Paros AR app, which is a augmented reality app currently used in concerts to add to the experience, as well as some basic data visualization. So if you want to use Unity inside of your engineering majors or comp sci to like visualize what certain data will look like in a new environment, you can use Unity to explore that without it having to be an entertainment-based application. So next, we're going to start by getting to know your editor and all the basic tools that come with Unity. So your Unity editor is going to be comprised of 5 major sections. You're going to. Before you continue, a lot of people don't have the editor up. Can I get a show of hands of people who don't have the editor up? Okay, that's some of you. So it's going to take a few seconds to open up your editor. I'm going to show you, just explain what the different sections are before we move on, so that you can also catch up. All right. So down here is going to be your project files. This shows a list of all the things that are currently in your project. By default, you have one scenes folder that currently has the current scene that you have opened. Here in the hierarchy is all the objects that are currently in your scene. Right now we have two objects, a main camera and a direction of light. Here is our scene view, which actually shows a three-dimensional, it shows the camera of the scene, which shows all the 3D objects currently in our scene. Here is a representation of our camera, and here's a representation of our light. On the right side of our screen, we have an inspector. If we click on any object inside of our scene, we should get more detailed information on it. And at the top of our screen, we have a toolbar, which has some basic applications such as your Unity account cloud storage, play, pause, and step through your scene, which will be more important later once we explore the game view, as well as exploring layers in the top left of your screen. I'm going to show of hands of people who have the Unity editor currently installed, or sorry, opened up. I should have asked the opposite question. Anyone not have it open up? Still a bunch of people. Just gonna wait a few more seconds. How are they doing, Jason? Okay.
I just have my own.
Oh, okay.
My mom bought one, like, and then she ended up taking it, and she had two, she took one professionally. So.
Yeah, I think we could. Now's a good time to do that.
While some of you are still working to get that loaded, Connor's giving me a minute to introduce myself. I'm Steven Miller. I teach in the computer science department, also immersive media. I teach CMSC 425, which is a 3-credit course for game programming that uses Unity. We also use Unity in IMDM 101 and IMDM 227. So if you like what you learned to do tonight, and you want to do it in the classroom environment where you get some credit for it, come talk to me and we'll figure out how to get you into one of those classes. My office is right over there. I'm Steven Miller.
Thank you.
All right, show of hands. People still opening up the Unity editor. Same group of people. So unfortunately, I'm going to have to move on. Hopefully you get to open up soon. I will be just covering up the toolbars before we get into any applications. So first, we're going to explore the toolbar, which has the account drop-down menu. This has stuff about your Unity account that you can access within the editor. It's not particularly important for what we're going to be going through today. In the middle of our screen, we have play, pause, and step through your Unity project. If you go ahead and hit play right now, on my Unity editor, my screen actually goes blue and actually switches from the scene view in the top left to the second tab over it, which is the game view, which shows the perspective of our camera that is currently in our scene. If I go ahead and hit pause, any actions that would be happening in game would be paused and nothing would actually move forward, allowing you to inspect various elements of objects in your scene while it's actually running. And we can also step through it if we wanted to see what would happen on any individual action. Unfortunately, since nothing is currently going on in our scene, this is pretty limiting on how useful it can be to us. And on the right side of our screen, we can see layout layers. We can see our undo history, which is very helpful if you want to figure out what your recent changes were and undo a specific amount of time. It opens up into this menu, which I haven't had any changes except for opening the scene. A global search, which allows you to search within objects in your scene. For example, I could search up our main camera, and it's able to locate it inside of our sample scene. There is, in fact, a main camera. We also can see layers. This has a bunch of different options that is more complex, that allows you to specifically associate objects in your scene. So if you wanted to see only things that are UI or only things that are on the default layer, you can choose to have them on or off. For example, our lights and our camera on our default layer, so I can toggle whether or not I see them. And layout. Right now, I don't recommend you changing the layout just to stay consistent with the workshop, but you can try out the different layouts if you'd like to have different various views. Please go ahead and try those at home. So next is the hierarchy window. On the left side of the screen, we have all of our objects in our game. A quick way to add an object to your scene is to go ahead and right-click inside of the hierarchy. From there, at the bottom of the screen, you have a couple of different options. I want to create a 3D object right now. So by hovering over it and then clicking onto cube, I will create a cube inside of my scene at position 0, 0. I can go ahead and give it a name. So I'm going to name it Play Cube. You can name it whatever you'd like or leave it as its default name, Cube. And interesting enough, on the right side of our screen, we've been given a whole lot of options. These options inside of our inspector are associated with the Play Cube. And have a transfer, a mesh filter, a mesh render, box slider, and a material. We'll go over all of these later, but these are called components, and they are a subset of the cube object. Inside the inspector, these are a bunch of different variables that we can modify, change, add, or remove to. And we're going to explore those in a little bit. Underneath, we have the project file system. Like I said, we have a folder down here called scenes. If I go ahead and double click into it, we have this object that kind of looks like the Unity symbol, which is depicted as a cube. On the bottom right, I have this little slide bar. Pro tip, if you want to just see things with their names on it, you can slide it to the left or slide it all the way to the right if you want a bigger like 2D image associated with it. I like seeing the images. That helps me associate what type of objects I'm currently looking at. If I wanted to, inside my assets, I could right click. This gives me more options, and I want to go ahead and create a new folder. So by going ahead and going to the top, I can go hover over create, and then at the top of that window, I can click on folder. I'm going to name this prefabs, and we're going to use this later to describe what a prefab is and how it can be really helpful at creating your game or any application you so choose to make. So a pro tip with all of your file systems, every file inside of your project will have an associated file inside of your file explorer. What's interesting though, if I go ahead and find, I'm just going to go ahead into one of my random projects real quick. If you want to open up your file location, you can. So in here, for every object I have the same object, and I also have the same object that has a meta file. A meta file is a file associated with Unity that describes what an object is and helps it run. And every object you create will have an associated meta file inside of your project system. So don't delete those duplicates because they're integral for Unity to identify what those are. But you can easily drag any objects you create either into the file system and it will appear inside your Unity editor if it has an associated object, and it will create that meta file for it once you add it to the file explorer or to the project itself. Okay, next we have the scene view. Go ahead, sit down. So we have this new play cube that created. If I want to click on it, I can pro tip click F and it'll focus in onto that object. So if I zoom out, I can use my scroll wheel or use your 3 fingers on your trackpad to zoom out. And I can press F to zoom back in on it. You also have a bunch of different tools associated on the left side of your screen. But the basic way you're going to traverse your environment is with the WASD or arrow keys. By right-clicking and using WASD and moving my mouse around, I can change which perspective I have around the object in my game. And if I wanted to get a specific orientation in mind, in the top right corner, I have these orientation tools. If I go ahead and click it, it'll force me into a specific perspective. And if I wanted to get out of this perspective, I can go ahead and right-click and use WASD as well as spinning to look back at my object. This middle button inside of it is orientation, which changes to an orthogonal view. It basically means that all of your objects are going to be at a right angle towards your camera. But most of the time, you're going to be in this default view. Yeah, what's up? So you're going to have to right-click onto the scene view and then use WASD. Awesome. Does anyone have any questions so far about the Unity scene editor or scene view? All right, moving on. All right. So here's an overview once again of the controls. Some of these I already went over. Inside your editor, another good tip to know is that you can press Shift at the same time as you're right-clicking, and this will increase the velocity of your camera. So if you have a really big scene it can be really helpful to traverse around a lot faster by pressing Shift. And as you can see, the world space here is quite vast, so many projects within a scene can become really big by just adding more and more of your own content. In the top left of this scene window, we also have these overlay tools. I can move these about, but I just typically have them right here. They give me a bunch of different options. If you don't want to right click every time in order to move, you can click onto the first view tool and left click and move around. That way you only have to choose one button. You can also access all of these different options with the QWERTY buttons on your keyboard. So Q stands for will be associated with the view. And if I press W, I move on to the next tool, which is the move tool. With this, I can move my object around inside of 3D space. I can choose to have it on a particular plane or a particular axis to move with, or I can grab the entire object. Sorry, I can only move it on those two things. If I wanted to, notice in the inspector in the top right, all of these numbers are changing as I move the object. If I wanted to have a very specific position in space, such as the origin, I can set this back to 0. Set this back to 0, 0, 0. And it'll be exactly where I want it to be. The next tool is the rotation tool. You can press E on your keyboard to reach it. It gives you this spherical icon that allows you to rotate on individual axes or on all the axes at once. There we go. By pressing into the center. Also notice on the right side of your screen, it's changing all of those values. So if I don't like this rotation and I want to set it back to its default, I can change all these back to 0. Next tool is going to be your scaling tool, which is going to be R on your keyboard. With it, I can scale in individual directions. So if I wanted to make this taller or wider or thicker or all of them at the same time, I can, keeping them in line with each other. So I'm just going to go ahead and make this into a large plane. And now I have like a floor that I can spawn other objects on. Does anyone have any questions about the tool so far? Cool. The next tool allows us to scale similar to the scale tool, but this is more useful for UI or elements that you want to have like 2D representations for, where I can drag kind of like your windows on your computer. You can drag from corners at diagonal angles and be able to scale them. If you want to rotate your scene view to one of the other sides, you're going to be able to there we go. So I can go ahead and take from this scene view and drag. For some reason I can't get that to work right now, but I can assure you, you are able to change all 3-dimensional axes with this tool. If I wanted to use all of these tools at the same time, I can press T and it gives me this, or sorry, Y, and I get like a multi-tool. This is a very complicated looking tool, but it has all the same basic features from everything that we've explored so far. Also, if I make an edit and I don't like, I can use the same undo button that most computers have, Control Z, and that'll go to my previous orientations that I just had, or undo my previous actions. All right, so we're going to go ahead and explore a little bit of the play mode. So when I go ahead and press play, it'll immediately go into the game view, but I can switch back into the scene view. What's really interesting about the play mode is I can make a whole bunch of changes to the objects within my scene. But if as soon as I go out of the play mode, it'll completely revert back to its original orientations or any settings that it had in the beginning of the scene. I'm sure some of you have noticed that whenever I go into play mode, my entire UI shifts to another tint of light blue. This helps me remember that I'm actually in play mode and any changes I make won't be saved over. So if you want to have the same coloration change to make sure that you're aware that you're in play mode, you can go ahead in the top left corner, hit edit. From there, scroll down to preferences. You might be on another tab, but on the left side of the screen, you can go to colors. And I've changed my play mode tint to a light blue. I recommend keeping it something towards its default white top left corner with any color you feel most comfortable with it and shifting it over slightly in the saturation. You can, of course, explore more of that on your own to find what color fits best, but I'm going to be moving on. All right. At the bottom of your screen next to projects, you have a secondary tab called console. I'm sure many programmers in the room are going to be aware that the console is going to show up for any text that is displayed within your program, as well as give you any warnings. This is going to be really important for whenever you're play testing or bug testing your code or making sure that all your actions are the same. Unity does a really good job at telling you when things are broken so that it will stop you from playing when things go wrong. And they will typically appear in the console. We're going to go ahead and make some simple programs in a little bit to really showcase the different features the console has at your disposal. All right. So that's the basics of the Unity editor and the scene view. We're now going to go into the basic building blocks of Unity and what it actually takes to create a environment in your scene and utilize all the different tools available within each of these sections. So I've been using the word a lot, scene, but I haven't really described what that is or what that means. So imagine a scene as a level in a video game. So every time you have a scene, you have different things inside of it. If I wanted to go back to my projects and go into the scene folder, I can right click and create another scene. I am blind. There it is. Scene is kind of in the middle towards the top. Once I create a scene, I can give it a new name. So I can say demo scene. And as soon as I go into this demo scene and save my changes in my previous scene, I'll have the same basic items that we had from before, but the cube I've created is gone and it will start blank. If I wanted to, I can go back to my sample scene that came by default and regain my cube that I created. Scenes are really useful for organizing your project. And if you were to make a multimedia application that requires different menu systems or different levels, such as a video game or applications that are really intensive, it might be to your benefit to create multiple scenes to separate the work. If you want to build a video game that is one giant world, I'm sure some people are thinking of like Minecraft or Skyrim in this sense. It is really difficult to hold all of your assets in one level at a time. So it's beneficial to expand out into multiple scenes. Like in Skyrim, every time you go into a dungeon, that would be like a new scene change where you're loading in different environments. And it's really good for organizational if you want to just test out all your things within one scene and then move it into another. So say, for example, my sample scene was the final scene I wanted to make my my content in. I can go ahead and use highlight everything from my sample scene, Control C it to copy, go into the demo scene I created. I can go ahead and delete the things inside this demo scene and paste with Control V all of my objects. So I was able to take everything in my first scene, put it into my second scene, and now if I wanted to test out what the play cube would be on different scales, I can, and that can exist in the demo scene. If I would like to quickly save my work here, I can hit Control S, as well as I believe File Save if you guys would prefer to use the menus. That way this is saved, and I can go back to my sample scene to work on what my final product would be, using the demo scene to play test any new features I would want to create. There's 3 levels to Unity. The scene view, which is everything that is contained with that we're currently working on. Inside of the scene view is our game objects. Like our play cube before, our game objects contain many things inside the inspector called components, which is one sublevel down. Components contain information on a game object. Game objects give information on the scenes, and scenes all together make up your entire project. But what exactly is a game object? A game object is kind of like, it's just a thing. It has representation that is being defined by its components. All game objects by default are going to have a transform. We can actually create a game object with nothing but that transform. If we would like to right click inside our plate, we can hit create empty. And this empty has nothing associated with it except for a position in space. I can go ahead and Control F, click in the scene view. There we go. So I can look in on this position in space, but there's nothing associated with it. I can move it sorry, if I actually can click on this axis, move it about so it's position change. I can change its rotation. If I want some particular value associated with rotation, it'll change. And I can even change its scale, though scaling nothing still makes it nothing. You're multiplying by a 0 here. But however, if I wanted to add something to this empty, we begin having more complicated materials. But those complicated materials start with primitives. Like this cube I made earlier, we have a bunch of primitive 3D objects: a cube, a sphere, a capsule, a cylinder, a plane, and a quad. Mostly you're going to be working with the top 4. If we wanted to, we can go ahead and add a sphere into our game and position it over our little floor that we created. Primitives are placeholder objects. So let's say, for example, we wanted to have a building inside of our game that would typically require 4 walls, a floor, and a roof. But we aren't necessarily 3D artists. We don't necessarily have all of the tools at our disposal to create the objects we want. So we can use these primitives as the basics for describing what we're wanting to create, just like I used a cube before to make a floor here. By default, the objects we create from primitives, like the sphere and the cube, are based off of 1 meter by 1 meter by 1 meter. So if you wanted to scale something to be, say, the height of a human, humans are typically like 2 meters tall. So you could use this as a basic representation for a human inside of your scene to get a scale for all the different objects you create around it. All right. Moving on. The next important object is going to be called a prefab. So let's say we really, really like this cube. Like it was the most perfect cube ever. Maybe it just had the exact amount of tilt that we wanted to make it as cool as possible, right? So this really tilted cube, this human-sized cube, is perfect. But we want to make a lot of it. And it would be really time-consuming for me to make another one from the hierarchy, scale it exactly like I want it to with all of these decimal places, and make sure that its position is exactly right in space. Instead, I can go to my assets, into the prefabs folder we created earlier. I can take this human-sized cube, drag it into the prefabs, and place it. Now I've created a new object in our file folder with its own associated meta file that is describing our human-sized cube. I can go ahead and drag this back into the Unity scene, and now I've created a duplicate of it. And I can do this as many times as I want. Prefabs are a really good organizational tool if you want to keep the things you previously made. And what's really cool about these prefabs is if I decide, you know what, maybe this isn't the best tilt, and I really just want it to be standing up exactly straight, I've completely changed this one specific one. And I can actually apply the changes to all other prefabs in my scene by clicking. Interesting. Sorry, technical difficulties. Wow, I don't know why that's not working. Here. Let's say I wanted to remove the renderer. The renderer is kind of describing what visually has the dimensions of this object. I could, for example, remove this and override in the top of my corner so that all of my different human-sized cubes will now be completely invisible. That may or may not be something that you want, but you can override them all at the same time. And if I didn't like that change, I can once again Control Z again to get my original one back, and everything is safe. So this allows you to have a tool that, say, you wanted to apply textures to a different wall, add or change objects. Maybe you finally found an object that you wanted to replace your placeholder with. Maybe I finally found perfectly wooden floors to replace my janky cube at the bottom of my screen. That would be a great opportunity to override all floors in my scene. And this goes beyond just one scene. If I wanted to change an asset in my demo scene, add in my prefab, and change it here to not have its mesh renderer like before by removing the component, I can override it here, and all of those changes will occur inside of my sample scene. So my override has affected multiple scenes now. I'm going to go ahead and delete these objects because I no longer need them. And we're back to just having our camera, our light, our floor, and our sphere. Does anyone have any questions at this time? So I'm going to go ahead and talk more about our components. Like I said earlier, the transform is something that all components have. There is no way for me to remove this component. It is there by default, and it's critical that Unity understands where anything is in space. There's a mesh filter and mesh renderer, which is associated with all of our primitive components. I showed before that the mesh renderer is what visualizes the object. The mesh filter kind of describes the geometry that that object has. It is more important if you're making your own or using 3D assets from other free websites that we'll talk about more in a little bit. There's a parent-child association within Unity. If you want to better organize your tools, your objects within your scene, you can actually manipulate them all at the same time by having them have a parent-child relationship. So this empty object that I've created here and this play cube that I've created here all have a distance in between them. But if I move just one of these objects, the other two don't move with it. I can move my play cube under the empty and my sphere under the empty. And now I can move all of these objects together in space. I can even scale them together so they all scale proportional to each other now that they have this parent-child relationship. This allows the new hierarchy to be seen, a game object, its children, and within all of its children, its components. So let's say we wanted to make the basics for our character, a player that's going to move around in your scene. Well, yes, we could use that perfectly human cube like before, but it doesn't have a mesh renderer. So let's go ahead and make a brand new one using a cylinder. Cylinders are more typically used in game demos. And let's make this a human. And our main camera in our scene, we want this to be the perspective of a player. So we can go ahead and move our camera underneath the human. But our camera is still, underneath our human, so it has a parent-child relationship. That way, every time we move our human around, our camera moves with it. But our camera isn't in the best spot. We can actually move the camera manually, and this may take some time as dragging it up and over and placing it completely right isn't always going to be perfect. Instead, we can use the command Control-Shift-F to move the camera exactly where I'm currently looking. So if I can Control-Shift-F and then moving out, our camera is now perfectly placed where I was looking inside the scene view. Now inside our game view, we're looking from the perspective of this human. We can go ahead and save that prefab if we wanted to use it for later. All right. So where can we get assets? So all of these objects are basic within Unity, but I'm sure some of you are going to want to use your student available assets from Sentry. In order to get those assets, we can go ahead and open up the Unity store. By Googling Unity Asset Store, we're able to find the Unity Asset Store and begin browsing multiple free assets. But if you already own something, for example, many of you have the Sentry bundle, you can actually access it from within the Unity editor. Inside of the top of your screen, you're going to see a button called Window. And you're going to end up seeing this button called Package Manager. This will open up a new screen. This contains a bunch of different files that are currently associated with Unity and whether or not they've been updated or not. And inside of it, you can find the Unity registry, which gives you a whole bunch of packages to work with that give you assets to either have programming that's within your scene that you don't want to make yourself, that somebody has already professionally made. It can be 3D and 2D objects and animations, so that if you're not an artist or artistically oriented, you can get those quickly. If I wanted to, for example, get any AR abilities, AR Foundation to allow me to make mobile apps with augmented reality, I can download it from the package manager. I'm sure a lot of you will have Sentry. So if you were to look up inside of My Assets, you can go ahead and search up the Sentry bundle and able to open it. I have this 3D Gaming Kit environmental pack. I can similarly download it, just like all of you would download your Sentry bundle, and go ahead once it's downloaded to install it. We aren't going to be using these right now, but this is an example of how you can get assets that you've either purchased or are free on the Unity Asset Store directly into your project. You can go ahead and cancel this for now, but this is all through the Unity Package Manager, which you can get to again by clicking on Window and then Package Manager. You can also open up the Asset Store through this, but it's generally recommended that you just use your browser to open up the Asset Store. But this is a tool that is built into Unity. All right. Like I said before, the Asset Store can be used to find models, script, particles, animations, and anything that you may not have skills to build yourself, you can find here. You can also find other 3D models on websites such as SketchFab, BlendSwap, NASA, TurboSquid, CG Trader, Open Game Art. These are all places where you can find free 3D models so that you can exchange your primitives for something that is more complex so that you don't have to make everything yourself and play to your strength using what other people have created. As it so happens, we'll be featuring a Blender workshop later this semester. So if you would like to learn how to make your own 3D objects that are more complicated than a cube, you can make them yourself. And using the tool Blender, you can create all sorts of things for any application you might want to create in the future. So I'm going to answer now what goes into building a game. We've described all of these different objects, but nothing happens. If I go ahead and play the game here, it's static. Nothing changes. There's no program that's going on. Even the camera isn't even looking at anything interesting. This isn't a game. This isn't a fun program, or it isn't visualizing anything interesting. But in order to do that, we have to talk about scripting. Raise a hands. How many people here have done any programming? Scripting is kind of the tool or the name for that Unity uses to describe all of your different programming files. The language Unity uses in order to create scripts is called C#. And it is object-oriented program. We can go ahead and create a new folder. Good to keep organizational folders for all the different things inside your project. So I'm going to name this one scripts. Inside of my scripts folder, I'm going to create a C# script. And once I create the script, this new behavior, I get a basic layout in order to write in all my scripts. It's going to take some time for Unity to open it, but if I want to open up this script, Unity doesn't necessarily, you will use your default editor, which I believe in this case is Visual Code. But let's say you have Eclipse or JetBrains Writer, and you'd rather use a different coding IDE in order to do this, to open up your program. We can actually change our preferences in order to use the IDE and get suggestions for quick code execution with Unity commands by going into Edit Preferences, going to External Tools, and this External Script Editor, I have it currently set to Writer, but I have Microsoft Studio and Studio Code, as well as Visual Studios inside of my computer. Go ahead and select whichever one of these IDEs you feel most comfortable using. And once you do that, any scripts you open from Unity will give you suggestions on related to specific Unity coding that will allow your job as a programmer to be much easier to build out the more complicated things within Unity that you may not necessarily be aware of from the start. So I'm going to go ahead and click Writer here, as that's my IDE. And I'm going to go ahead and close out of this. Now, whenever I open up this script, I'm going to actually launch my Writer coding software, as well as the script that's currently in it, so I can edit it and add more functionality to it. Go ahead and trust and run, so we can make a project out of this Unity editor, or sorry, the associated with the Unity project itself. So I'm going to go ahead and talk about the life cycle of a script. So all of your good scripts are going to start in the editor mode. This allows you to have your inspector values associated with your scripts, just like inside of inside of our human object, we have the cylinder, mesh render, and capsule colliders. I can go ahead and add the script that we just created. New behavior script. You don't have to go ahead and do this now, but just an example. Underneath the script on the left side of, on your right, it doesn't have anything associated with it, but I can add data just like how the capsule collider has these different materials, just like the transform have these different vectors that allow scripts to hold information. And all of those can be changed in editor mode. Moving past that, once we enter play mode on our Unity, or when your game is running, once you've built the application, it'll start in startup, which has an awake and an on enable as well as a start method. These all run before your program starts and allows things to be set up. So if you need to make sure certain values are consistent at the start of your program to clear or instantiate anything, that would typically happen in 3 of these functions, and each one is built for specific purposes or to order operations, and you can explore more of those on your own. And we will be doing a demonstration with the start method in a little bit. After that, we follow into the update method, which happens every frame that your application is running. Frames depend on how fast your computer is running, so more power-intensive computers would have more frames per second, and things will be able to cycle faster. There's also fixed updates that happen over a specific amount of time, but update happens pretty quickly, typically 60 to 400 times per second. An update is very quick. After that, we have rendering, which is going to trace all of your 3D objects, then your GUI, then your teardown. And so teardown happens at the end of your applications with everything typically cycling in update and rendering. Anyone have any questions? Cool. From this, we are going to utilize the debug output on our console to write a first program inside of a script that you just created. It by default comes with a start and an update function. As it says, start happens at the beginning before any update is called, and update is called once per frame. Within start, we can go ahead and do a debug.log. And this is very similar to a print statement in other coding languages, and this will appear in my console. So I can say this is a general message, and will only happen once. So you can put anything inside of this quotations, but the main thing that's important is debug.log, parentheses, or sorry, parentheses, then quotation marks, and then your message ended with a semicolon. Inside of update, I can add a debug.log warning. And warnings are typically things that Unity will create for you. If things aren't to Unity standards, if things are a little off, it will display a warning. And this warning is to let you know we happen every frame. So warnings won't stop your program. It typically means nothing is wrong, but maybe you need to be aware of something that could be improved upon. And Unity will generate a bunch of different warnings, or you can generate your own warnings like this yourself. Finally, we have debug.log error. This is an error. And errors you create yourself, I don't believe will stop your program, but any errors created by Unity will halt your program and force you to reconcile the error before it's going to continue through your script cycle. So for example, if I had an error inside of my startup, for example, there's an error that occurred whenever I was initializing things in start. It will stop my program and not a single frame of update will begin. Similarly, if after 5 minutes in my update, an error occurs, something went wrong, it will completely stop my program and prevent anything from continuing. Once I go ahead and save this script, many editors will require you to hit File Save or Control S. I can go back to Unity, where it's going to recompile all my script to make sure everything is working as intended and may give me some errors in my console. Luckily, this time around, we have escaped danger and everything works perfectly the first time, like all programmers want, never to dealing with debugging. But unfortunately, as soon as I go into the play mode, my console is going to fill up with various different errors. Most of you will probably see a stream like this, where it's one warning after error after error. If you'd like to simplify your view, you can hit collapse. We'll collapse all your different warnings and errors into just the number of times they occur with a label next to them. So these two are happening every single frame. If I wanted to, and I'd be like, you know what? I don't really care about the messages or the warnings right now. I just want to know what's really wrong with my program. I can hide those two warnings and comments in just focusing on the error. Conversely, I can also just look at those two if I don't actually care about the errors right now. So this can help you focus on what problems you actually want to solve or acknowledge at any particular time. Does anyone have any questions about the console or debug logs or any errors? Cool. Has anyone not been able to get that working or like code these debug log scripts? Syntax error. So yeah, just can go ahead and help you. But otherwise, this is pretty simple. The basic functionality of your program is going to be dependent on your need. And we're going to be going over more of like more complex things you can do with your script in next week's workshop. Pro tip with this script lifecycle, you can actually change the order that certain things happen. This is all by default. And DJ, do you mind showing where you can change the script lifecycle from? Yeah. So most of these things are by default and you'll want to keep them that way. But if you become more savvy within Unity, you can decide whether or not awake happens before enable and all these different functionalities. But by default, you probably want to stay consistent with these things. Yeah. But you can change these options here inside of your project settings and then go into script executing order. Again, I recommend you don't change any of these things, but these are tools at your disposal if you're feeling like you want to explore more complicated facets within Unity. And it really shows you about the versatility this development software can give you. All right. So if we wanted to build out a script and actually give it more properties that we can see within Inspector, we can go back to our script inside of our IDE. I have Visual Studio Writer, and I want to give it some instance variables, right? So many of us are familiar with it. If we wanted to make, for example, a public, let's see. I think the script I have on screen is being set for a player controller by default. So I can make a mouse sensitivity. So public mouse, public float mouse sensitivity. And now once I've created this object and go back inside Unity, I can actually see this associated inside the editor. So inside my human, I have the script, the new behavior script, with now mouse sensitivity, and it's set to 0. I can go ahead and change this to another value, and this will persist inside of my scene. Or if I want to go into play mode, I can play around with mouse sensitivity as it's going on. So say inside play mode, I wanted to set it to 99. Again, it won't save. As I go back out, it'll default to 10. I can also make private variables visible within the inspector. So maybe I want private variables for protection inside of my code, and I want it to reference a game object. A game object, like we described before, is any object within scene. So maybe I really wanted a reference to the floor. So by default, a private variable isn't going to be visible inside the inspector. I can go ahead and check, and lo and behold, I don't have any new options. But I can force it to be visible, and though no other program will be able to access it besides this new behavior script, I can ensure that through serialization, if I can spell it, serialized field, this one line will ensure that the very next line, or if you want to simplify it and have them be on the same line, will appear visible within the inspector. Sorry, I believe it's supposed to be serial. sorry, I think, did mine just not compile before I looked in? Compiler errors. Oh no, what have I done? Did I not capitalize the O in object? There we go. All right, so we've exposed this floor variable. So now it's visible with inside of our inspector. And it's really useful to have these different objects. Now, if I wanted to reference the floor, I can go ahead and take inside of our empty. We have this play cube, which I'm going to now rename to floor because that's what I'm using it for. And I can go ahead and take the floor by clicking and dragging it into the reference inside the new behavior script. So now whenever I'm programming inside of this, if I need a reference to the floor, I now have it under this variable, which we've serialized for the inspector to see. For even further organizational stuff, we can make sure that things are specifically related to each other. So if I wanted to serialize this, I can also add a header so that in quotation marks, I write reference. By doing that, it changes the layout of your inspector to make sure that it has a header before our floor. And this can really help you organize things for a visual sake and help people that aren't necessarily programmers understand what is going on here. So now all of my references, for example, our floor, are organized now. So if you want to get access to the many scripts that are default within Unity, it is a great tool to use the Unity documentation. I can easily find that by going into my browser and searching up Unity documentation. Or Unity manual. And this will open up everything I need to know that is built into the scripts within inside Unity. Perhaps the most important documentation that everyone here should look at when they have free time is the mono behavior script. I can go ahead and search for it if I spelt it correctly. I have a feeling we are all doing Google searches at the same time, and thus the internet is slow. All right. Here you go. So the mono behavior script, if we go back to the script we just created, it is a child of the mono behavior class. I believe I can press F12, F10, F11. In my editor, I'm able to find uses. Nope. Sorry, technical difficulties. I'm trying to go ahead and inspect this. Anyways, every script you create by default will be a mono behavior. You can go ahead and change this if you would like, but a mono behavior as a parent is necessary for any script to be applied to any game object in your scene, and it will imply that it will have an update function. So any start function and update function is because of the mono behavior script. And if we want to learn more about other different functionalities of it, such as on disable, on enable, or many of the other functions that you can implement by just having it be a mono behavior, you can explore through the Unity manual. All right, so in order to build your own game, when leaving this workshop, you can go ahead and try easy examples by trying to make your own environment with free 3D objects from the Unity store. For example, I encourage you all to make a small forest or a bedroom and see what kind of objects you can find to really build out the environment. As a medium challenge, you can make a skybox appear darker or even change it into a starry night sky. And you can research those things through the Unity manual or by finding tutorials on YouTube. A harder implementation would get the player controllers or camera rotations working with the script. There are a lot of built-in functionality and, again, YouTube tutorials in order to get you started in order to handle this. If you're feeling so bold, you can use the new input package inside the package manager, which gives you the most complex up-to-date tools in order to handle your character's creations. Next week, I'm going to be giving you an unfinished game in which we will cover more advanced features. The player controllers and environment will be provided for you, and we will give a link in order for you to download the packages necessary in order to launch this application. In order to build upon this and make it your own unique creation. For any more searches, I recommend using Brackeys as a starter channel on top of YouTube. You can use any specifics off on the Unity documentation. If you are more inclined to use forums, there's Unity Answers. Again, programmer's greatest tool is Google, so please Google all of your problems. And if you want to have a more formal instruction guide, similar to the workshop provided by XR Club, and that will provide you with some basic tools in order to get started, you can use Unity Learn. And please join our Discord. On our channel, there is many users available to answer any quick questions for you, give you resources, importantly, give you opportunities and showcase different ways you can apply your Unity skills into a job market. Go ahead and contact us or email us or join our Discord and answer further questions.